Hello everyone and welcome back for the engineering mechanics lecture series. We are previously discussing module number 2. This is lecture number 2 for module number 2. In previous lecture we was discussed about the basic concept of centroid, center of gravity, how we can calculate the area and the coordinates for various standard geometries. Okay, so today we will continue the same module with another problem. So next problem, in this problem there are various different geometries as shown in figure. Okay, so if you want you can, I will highlight the type of geometries. This is a semicircle which we are able to see. Then next one, this one is a rectangle. Okay, I hope everybody is looking it properly. And there are two triangles. Okay, so the main geometries are semicircle, rectangle, and two similar triangles. Okay, I hope this is clear to everyone. Okay, now further we'll go forward to calculate the areas for one by one. So initially, to identify the exact centroid location, we need to first uh, check whether the geometry is symmetrical or not. Okay, and this geometry is symmetrical to the y-axis, so the all x coordinates are getting 0. Okay, and the areas we have already seen, that triangle, rectangle, triangle, and semicircle. For 4 geometries we can get 4 different values of y. Okay, and that we will be used to find out the standard value, standard coordinates of center of gravity or centroid. Now let's consider first triangle ABH, which is shown in figure. The area is calculated at its width is 10 and height is 30 centimeter. Okay, as per the equation h by 3, we have calculated the y coordinate. Next one is a rectangle. The area of rectangle is L by L into B into H. So 20 centimeter into 30 centimeter, and the y coordinates is H, or you can say H by 2, that is 15 centimeter. Now considering the third triangle, another triangle which is equal, which is similar to that of first geometry, that is a triangle. The values will be similar to that also. Now next one is a semicircle. For semicircle we know the area is pi r square divided by 2, and the y coordinates are 4r divided by 3 pi. Okay, so based on this we find out the area. Here the area is getting negative because we need to subtract that semicircle area from the rectangle, and we need to add triangles in the rectangle so that we can achieve the exact shape which is given as per the figure. Okay, to find out the centroid, the equation is y bar is equal to a1 y1 plus a2 y2 plus a3 y3 plus a4 y4. As area we need to subtract, that's why the sign is given as a negative, divided by a1 plus a2 plus a3 minus a4. Okay, so one point is to be noted over here: whichever area is going to be subtracted from the stand any area, The subtracted area is always indicated by minus sign, so that that area can be removed from the total area. Okay, so you will get the value of y, and with respect to the, as we know, the x coordinate is getting 0, so value of y location, that is center of centroid for this given profile, is 15.26 centimeter. Okay, so i I think it is quite much easier to understand how we can solve the problem, how we can identify the various different shapes, how we can add or remove different areas, so that we can achieve or we can able to identify the centroid, because ultimately we need to identify coordinates for each and every area, and after that we are clubbing together and identify the exact coordinate for centroid. Okay, so let's see the another example. Okay, read example carefully. Three plates ABC, BCDE and DEF are welded together, which is shown in figure, with a circle of diameter 1.5, and the and it is cut is made from composite plate. So determine the centroid of remaining area. Okay, I hope you initially analyze what are the different geometries, standard geometries need to be added and need to be removed to get this profile. Now let us consider, we can easily use ABC triangle or ACB triangle. Then there is a rectangle, that is BCDE. Then there is a semicircle, that is EFD semicircle. Then there is a one circle which to be removed from semicircle, that is a half semicircle from, you can say, rather than half, you can directly remove that much circle area from the whole geometry. Okay, so let's further move forward. As we discussed, there are four geometries. Out of that, three geometries are getting added and one geometry is getting removed. Now, as for figure, the four geometries we have already discussed, that is triangle, rectangle, semicircle and circle, having a radius 0.75 meter. Okay, now in previous problems we actually calculating with the help of formulas, and I hope so you are totally aware with the formulas, that is to calculate the areas, to calculate the x quadrant and to calculate the y quadrant. Okay, so based on this we have standardized this table for better calculation or too easy calculation. Now for triangle, we know the area 1 half L into B, that is 3 1 half 3 into 4. Okay, as the radius is 2, so the diameter will be 4, so height will be the 4 for triangle. Okay, so based on this you can get the values for triangle. Area is 6, x quadrant is 3 divided, sorry, h divided by 3, that is 2. Now multiplication y quadrant, that we can find with the equation. Okay, and multiplication. So I hope everybody is getting the this equation. Now for rectangle, we know width and height, that is 3 centimeter width and height is a 4 meter, 3 meter height, 4 meter, sorry, 3 meter width and 4 meter height. So based on the previous equations which we have standard understand area and x coordinate and y coordinate, we have calculated the values which is required. Now moving forward with a semicircle, similar process we are following over here also, and find out the values for circle. Now we are going to remove this area from the areas which are added by triangle, rectangle and semicircle. Okay, so that minus sign is given to so that we can actually get the shaded area. Okay, so total area which is shaded is 22.52 meter, and we need equation that summation of ai xi divided by summation of a. So that values we having with us, and we can directly calculate the x and y coordinates. Okay, so calculating the location x bar and y bar for composite area. Okay, so finally we are eliminating the unnecessary part, and directly we are shown the exact profile from which we need to for which we need to calculate the centroid. Okay, so x bar y bar is nothing but x coordinate and y coordinate of centroid, which is 4.37 and 1.82. Thank you very much for uh, listening a lecture carefully, and I hope this topic will give you the maximum score, because it is very easy to understand and there are few formulas which you need to be remember. Otherwise uh, we need we need to only understand about what we need to just recap the whole same module. First of all, we need to understand we these two equations to calculate the x coordinate and y coordinate. ठीक है, ये दो equations important है. Next, remember this whether the uh, geometry is symmetric about any axis. If it is symmetric with x-axis, y quadrant will be 0. If it is symmetric with y-axis, x quadrant will be 0. Okay, and for 45-degree incline, x and y will be equal. Next, areas. We know the areas. We can easily calculate the areas. Now, to understand the centroid or central location, x and y coordinates for various standard profiles. For centroid to rectangular area, y bar is equal to h by 3, x as y axis is symmetric, uh, profiles are symmetric in y axis. For semicircle, the value of y bar is equal to 4r by 3 pi, as we know that this area and this area is symmetric along y axis, so x coordinate will be 0. In circle area, the value of x is 4r divided by 3 pi, and these this is actually symmetric along 45-degree line. This angle is a 45 degree, and both profiles is similar, this one and this one, so that the value of x bar and y bar will be equal for 4r divided by 3 pi. Then centroid sector for circle, sector of circle. This is equivalent in y explain. So x bar is equal to 2r sine alpha divided by 3 alpha. Okay, so again you can find out the x x1 y1 or x and y. Here only y, here also x and y. For rectangle triangle, you need to understood the difference between equilateral triangle or isosceles triangle, normal triangle and right angle triangle. If you look at in equilateral and normal triangle, the value of x is equal to 0 and y is equal to h by 3. But in right angle triangle, both having a value because in 45-degree it is symmetric. So the value of x bar and y bar is equal to h by 3, or you can say b by 3. Okay, next for circle, the y factor symmetricity is in y action, y axis. So the value of x is equal to 0 and y is equal to 4r divided by 3 pi. For quarter circle, it is symmetric about along the 45-degree. So that's why the value of x bar and y bar is equal to 4 upon 3 pi. Okay, and here the symmetricity is along x-axis, so y coordinate is getting 0, and x coordinate x bar is equal to 2r sine alpha divided by 3 alpha. So these are the equations you need to be understood to solve any problem related to centroid, and you can make the table which is shown in last problem. Okay, you can make similar kind of table to, so that you can calculate proper values and proper equations, proper values of areas, x coordinate and y coordinate, and finally the exact location of your centroid. Okay, I hope uh, this module is quite simple and interesting for you. I hope you will enjoy this previous and this lecture. And if you have any doubt, you can feel free to contact me anytime. Thank you. And the attendance sheet link is given in the description box, so you are able to give attendance. Thank you. Thank you very much.